Hey guys, welcome to our lesson on probability, dependent and independent events. We're going to be talking about these terms and putting some real examples to them so you can get a better understanding of what they mean. But before we do that, we need to recall our general formula for probability, which is always going to come from our desired outcomes divided by all possible outcomes. And remember, when we're talking about probability, you'll come across the term sample space also, and that is referring to all your possible outcomes. Okay, so we'll jump into some events and some examples of those. So you're going to hear a lot of words here when you start studying these topics. You're going to hear independent events versus dependent events. So sometimes when you're dealing with probability and you have an event, you have a second event or a third or fourth, sometimes each of those affects the next event and sometimes they don't. So let's take a look here. When we have independent events, that means that the probability of one event is not going to affect the probability of the other. For instance, if you have a dice and you have a coin and you flip your coin and you roll your dice, the coin has nothing to do with the dice, has no bearing on the chances of what you're going to get on the dice, so those are independent events. Dependent events is where the probability of one event does have an effect on the probability of another. For instance, picking a card from a deck of playing cards and then picking another one, a second draw, without putting that first card back. That's going to affect your chances of what you're going to draw on the second draw. So without replacement is always a dependent event. Alright, we need to talk about sets. Intersecting sets versus disjoint sets. Intersecting sets, they're going to have at least one common element, at least one thing in common or overlapping. So for example, think about all the people in the world who own a dog and all the people in the world who own a cat. If we put all the dog owners in one set, all the cat owners in another, it's not totally disconnected because we know some people own a dog and a cat. So this would be an example of intersecting sets, since we have some members who will be in both. Disjoint sets, however, will have nothing in common. So, for instance, set A, if we've got people in the 5th grade, set B, people in the 10th grade, we're not going to be in both of those grades at the same time, so those will not have any of the same members, so those are disjoint sets. Alright, so we'll take a look at an example. Suppose we have a box of marbles here. We've got 2 red marbles, 1 purple, and 1 green. And then in another box over here, we have some letter blocks. We've got 3 A's, 1 B, and 2 C's. I'm going to use these sets to kind of pick apart these terms a little more. Okay, so for example, and you can take this too after we've reviewed and practiced on your own and see if you can come up with some of these from these sets. Independent events from disjoint sets. Recall what that means. Independent events from disjoint sets. If we pick one from the color set, let's just say this one, and one from the letter set, those events do not have anything to do with each other because they do not have any of the same elements. We've got all letters in one box, all colored marbles in the other, so they're disjoint. And the events are independent because one does not affect the other. Now let's talk about independent events from intersecting sets. So we're going to take a look at doing 2 draws from the same set. So that's why they're intersecting. They will have all of the same items for the first draw and the second. So all the same elements. So if we pick one from this letter set over here, take it out, and replace it, so we're going to put it back in before we do our second draw, then both of those draws are going to be independent because I'm replacing the letter block that I drew out to have the exact same amount in the box for my second draws. The exact same amount of each item, the exact same total. So that's why we have independent events. One will not affect the other. Okay, and lastly, let's look at dependent events from intersecting sets. So let's focus in on having 2 draws from the same set again. So that's how we are talking about intersecting sets. Our first draw has the same items as the second. We're going to use the same box of letters. But this time, let's pick a letter block out here, leave it out, and not replace it. When I do that, that changes the amount of letters of whichever one I drew out of the box. And it also changes the total amount that are in there. So that's why my second draw is going to be affected by the first draw, no matter what happens, because I'm not replacing it. So we call that dependent events. And this is going to conclude our lesson on probability, dependent and independent events.